So, hello everyone. It's now 5 p.m. here in Ukraine and 4 p.m. in Central Europe. So, basically, I want to welcome all of you on board of this series of functional safety webinars. Today, we have our fourth gathering on functional safety, and I am your host today, Alexander Lubimov, and my co-host is Vadim Dolgopoly, who will be presented a little later. So today, we have been basically doing free webinars already, and today we'll be talking about a little bit more, I would say, practical stuff rather than some theory we have been covering previously. So let's go through it and let's see what's up for us today. So first of all, I would like to say that we will be following the agenda that you can see on the screen. So we will be discussing, well, first of all, why the hell tools are needed for functional safety process and projects. Then we'll be going through tool types and the efficiency definition for those tools. So what is effective tool, what is bad tool, what is good tool, so to say, to put it short and simple. And then Vadim will guide you through some extremely practical and I would say awesome and effective practical tricks for functional safety projects. The ones that were probably gathered by Vadim by pulling a ton of hair from his head during the mistakes and some pitfalls he was falling in. And then we'll kind of wrap up and have a Q&A session as well. So that's the plan for today, and we'll be following this plan. So a little bit about our previous sessions. We have started back in July, I believe we started, or June actually, sorry. We started as introductory course about functional safety, what it is, why people would want to use the functional safety I would say approach and the design rules. Then on webinar number 2, we have been covering so-called architecturing functional safety projects by actually addressing how do we do the architecture, what are the architectural needs, why we want those architecture to be done at first place and stuff like that. Then in our previous webinar number 3, we actually did quite a bit of discussion on the process side, because one thing is to have your target point somewhere in the project, but another thing is how to actually go from the beginning of the project to the final destination of the project design. And obviously, with correct processes at hand, you'll be really mastering the process of developing functional safety projects. And today, as I said, in introductory word, we are talking about tools, tricks for functional safety projects. And actually, we will have a small Easter egg announcement in the very end of this webinar, but let's wait for that for the moment. So, okay. Well, two words about us. My name is Alexander Lubimov. I'm a business director in EKTOS development. So I've been doing quite a bit of projects, both functional safety and just regular electronic embedded software commercial projects. And I'm responsible now for the business development within EKTOS development team and our customers. And we have Vadim Dolgopoly, who is our technical solution architect and the functional safety god of projects, let me put it this way. So basically, despite knowing that Vadim is atheist, he is still god of our functional safety. So that's who will be presenting the materials for you today. So let's get started. So the first part, what we're gonna talk about is actually tools for functional safety projects, and why we need those tools. And let me start actually dwelling the data here. So first of all, I would want to say that tools are super important and essential for functional safety projects. And here on the screen, you can see some key drivers why we need tools to be in place before we start the project. First of all, we apparently reduce systematic errors, so we are not falling into the same problem all the time. We can enforce consistency, and we can follow the coding standards or whatever other standards and processes we have in the organization. We can provide traceable and auditable outputs, so meaning that we can preserve the data we gather during the process, so we can actually use it as the evidence during the audit and functional safety case demonstration and preparation towards the certification body. And basically, with tools, like always, first of all, we can put our process to be repeatable. One thing is to put the process on a paper and then ask everyone to commit to it. Another thing is that when you code the process into the tool chain, and the tool chain automate, tool chain also limit you within what you can do, what you cannot do. So, and then in this way, we actually visualize and kind of put on the surface the risks we can face during the process. And then again, as I said, we automatically produce the evidence set. And that's really important. We'll talk about that a little bit later in the presentation. So basically, if we combine all that into the one ideal tool chain we can imagine in our brain, then this tool chain shall be able to basically automate the whole process of assessing our functional safety hazards, how they actually challenge the safety goal, how they reflect it and change the safety requirements, software requirements, code commits when we actually do development, test cases, results, and in the end, how we embody all that into safety case claim. So that the ideal tool will really, and tool chain will really concentrate and allow us to have all these parts fixed within the same tool chain. Unfortunately, the bad message is that there are no tools that can do it all just out of the box. Probably there are some, but they probably cost a little amount, and also their kind of introduction in the development organization will definitely challenge the organizational culture and also time to market. So that's why we'll be talking about some of the tools we use and how we can kind of integrate some different tools to be able to cover all this what you see on this rainbow of our artifacts and parts of the process here. So if you look into the taxonomy of tools we actually shall have when we address functional safety projects, we need some tools that help us to work with safety analysis, so we can actually generate different artifacts like hazard logs, like fault trees. You can see the abbreviations and also, you know, failure modes and effect analysis or diagnostics as well. So that's the safety analysis part. Then we go to the requirements and change management tools branch, and we need to be able to obviously capture and store the requirements, review them, trace them down, make change management. So if when something changes, we can actually trace it down, and the artifacts we normally generate are baselines, review logs, trace matrices, and some signatures when we actually kind of make a snapshot of the requirements to be able to start particular sprint or gate of developing the projects. Then we have a branch called development and code quality. So here we have all different things like code analysis tools, coding rules, coding standards, and stuff like that. We have also the process part, like code review gates or peer review gates, different things. And the artifacts we normally obtain from here is rule violations, also waivers and rationales connected to those waivers, so we can actually understand why the development team was waiving some of the specific, I would say, decisions or challenges, violations in that regard we have seen, and also do some regular records about, okay, this is the process where we in this process we did this, we did that. Then we have verification validation part of the tools here. So in here we need to work with basically coming up with design of the tests we want to do, with managing the tests, automate them, do some unit testing, integration testing, including hardware software model in the loop integration as well, working with the test coverage and fault injections in that regard. So, and the artifacts are normally test results, coverage reports, and stuff like that. So, and the last part of the tools taxonomy would be configuration and release evidence part, where we work with, I would say, sources and configuration management. We work with version control tools, work with continuous integration and deployment policies and pipelines, software bill of materials, and stuff like that. So basically, here we generate some, I would say, build blocks, released manifests, basically quality records, and in the very end, safety case package, which we obviously would want to have in the end of our journey. So how do we make sure that the tools we have are efficient? Well, first of all, I try to come up with my vision, and this is also, I would say, like an industrial practice targets. First of all, we want to, to have downstream traceability of requirements to be more or equal to 95%. So meaning that we want to have all the requirements traceable and being down traced to all the architectural or implementation details. The second efficiency requirement and metrics I would suggest to use as quantitative measure would be that if we have the top level change in a safety requirement or product requirement or hazard registration or analysis list, we would want to have gap analysis or impact analysis to be done within 15 minutes. So we need to have some sort of documentation and traceability system that can allow us to more or less immediately see what the change that we just introduced means in terms of the whole development process and what does it challenge. And last but not least, which is super important thing, when you actually come up with the safety case claim, you want to have fully automated gathering of all required evidences into the evidence pack. So, and in reality, what we see from a lot of vendors around the world that it takes weeks because it always comes as a surprise, as a pile of snow during the summer. So, and the target here would be to have evidence pack generation within hours, not within weeks. So that is the definition of toolchain efficiency whenever you consider a specific part of the tool from the taxonomy that I presented to you on the previous slide. So let's, before we go into the some of the major pillars in this taxonomy and discuss our experience and what we suggest to use, I would want to concentrate on issue tracking and task management tool as a key, I would say, glue that connects all those pillars that I demonstrated during the taxonomy presentation. So before we start doing something, we start the process of doing stuff. We need actually to be able to make our our different parts of the process to be able to drive this, to be able to create some tickets or some assignments, tasks, so we can actually do things in a systemized manner. Let me put it this way. So first of all, why it's important to drive this in this way is that one, we need to be able to actually split functional bugs and tasks that are related to functional safety or the other ones that are not related to functional safety. So this is super important to do so. And we need also to be able to demonstrate how we approach the specific task or specific part of the project within the amount of issues or tasks we have in the development team to auditors and assessors, so they can actually see that we have been approaching the readiness or the maturity of the project, not within one night, but within a specific period of time, and they can also assess the efforts we delivered to the product or project, and how we matured the product. So that's very important. So then it helps us, basically task management and issue tracking helps us to provide some very flexible links between tasks, their connection to hazards or safety requirements or diagnostics or safe state logic. So we can connect different activities, different tasks to specific domains or specific I would say tasks we have in the process or parts of the process. So it really helps us to group things logically and assign specific people to look over that. So, and how does it impact the safety? Well, first of all, it helps us to play with the priorities and document, how when we fix something, we can document that it has been fixed. The task has been done, and efforts are spent, so we can measure our velocity and stuff. And then we also demonstrate to the assessors that we actually do have live process behind the product development. So that's why I really wanted to concentrate on this issue tracking task management at first place. When we look into the next part of the taxonomy, I think all these names for sure, but what is super important is to have version control and configuration management in place before you start the process of development. And I know many of you will say today that, well, everyone have that. Well, some still use some shared folders or whatever else, really simplified like daily offloads of firmware being developed, of hardware being developed, and that's not going to fly in functional safety projects. So what you need to do is to have good version control system which is configured and ready. And why? Well, first of all, you need to register and be able to present those auditable artifacts or evidences that actually there is a specific life cycle of different features. You need to have a robust mechanism that will not allow people who are developing the process, the product, to actually do something wrong. You need to use your basically version control is the only and the only. I'm really emphasizing this place for your most recent, most common, most tested, and presentable to the assessors part, like artifact, like one um, unique artifact you have created through the process. It must be a part of the CI/CD pipeline. And I think last but not least, and super important thing is that it allows actually co-working on the software. So instead of just sending your pieces of the code back and forth after fixing some stuff, you can lean on good mechanism of version control servers to be able to work collaboratively. When we look how it actually gets into the CI/CD server pipeline, and normally I'm pretty sure that all of you have the CI/CD servers as part of your development infrastructure. You can see that we are undergoing specific I would say, steps and undergoing specific activities from building the code. And this is where the, fetch from here, from cloud repository. This is, one of the specific examples of the version control. We fetch the code, we build it, we make the analysis by different, tools. We will be talking about that. We test our code also through specific steps. We generate reports. We merge when we believe that this is the good way to add this add-on or sprint result to the main branch, and then we deploy it so it's ready for whatever, for delivery to the customer and whatnot. And basically, why it's important to have the continuous integration deployment in place. Well, it allows repeatability, it allows process control. So you once building the pipeline or several pipelines, depending what you want to do, you can ensure repeatability, and it completes and fulfills the traceability requirements. So it's really important that we can always trace back, we can always demonstrate that things are done in a proper manner. The next thing, the next pillar in the taxonomy is static code analysis. In here, it's super important to understand that the code analysis also requires specific process. And here, our suggestion how to build the process is done in a just a numerical, top to the bottom manner. So you define your coding guidelines and internal code style. Because you can, take it from the application specific standards or whatnot. You select the static analysis tool that reflects one, your requirements to coding guidelines. It reflects the requirements that you get from the standards you have to comply to, and it also fulfills your maturity level. So not necessarily you should not necessarily start with extremely expensive stuff to do static code analysis. You can start with simpler tools. Then when the team gets into the maturity mode, you can switch to more sophisticated tools. And then you integrate the tool you have chosen into CI/CD pipeline, so it's all automatically hooked whenever you want to build, the source code of your product. You configure rules and thresholds, so you get specific notifications when there are some specific violations in the code. You analyze and remediate, or triage specific problems that system reports to you. And what is really important also to emphasize here is that you analyze the cyclomatic complexity. Why it's important? Some standards prescribe requirements to cyclomatic complexity. To put it simple, for specific applications, your code must be simple instead of just being extremely sophisticated, made in a sophisticated manner, and then you document and report. So basically, that's what static code analysis does, and here is the process from 1 to 6, how to actually provide the excellence of static code analysis in your team. Here on the right side, you can see some super commercial, super fancy tools for static code analysis, some open source or free tools that will help you to enter into the game and just figure out what you can do. These tools like CLang, Tidy, or CPP Check, they're also pretty capable, but like always is open source, less intuitive, a little bit harder to build, to start using and stuff like that. What I want to mention here with this simple but important quote is that static code analysis investment is probably the best thing you can do in the very beginning, and it definitely pays back super fast. So I would suggest you to do this in your projects extremely early. Unit test and coverage tools. Well, many of you know what it is. Basically, it helps you to catch defects early, and it helps you to kind of integrate and build up the test coverage step by step. So basically, standards are prescribing specific requirements, and I would suggest you looking into the standards to understand what requirements are required for your specific product. The coverage requirements, especially for the bigger code, are important to remember and fulfill. traceability is generated and supported automatically, I would say, by the use of unit test idea and coverage tools idea, because you can always document to the most low-level requirement what is covered by testing, what is not covered by testing, and where the results. Independence is super important thing as well, because instead of hair pulling exercises when you have a classical peer review by another person, you have generated set of rules, generated coverage you want, and then you just anonymously, or not anonymously but unambiguously, you get the feedback from the tool chain saying, well, there is probably some sort of problem here or there. So that's really, really good, because it kind of helps us to reduce ripple in the development team and calm down developers whenever they see some problems. And then last evidences, like always, you must remember that you need to have evidences. So, and on unit test and coverage tools, I would say mainly the ones that are making static code analysis, they also provide unit test and coverage tools as well. So you can see the same name, like Parasoft, like Vector, like Tessie. So basically, you rather consider the same vendor for both unit test and coverage tools and static code analysis, because then you have probably easier integration, easier build up of those tools into the pipeline itself. And well, there are some open source stuff as well, which is pretty okay. And then the way to choose the tool is, first of all, to understand if you have specific requirements and specific compliance towards pretty high level of safety integrity. Then you can go one way and prefer and look into only fancy stuff, or you can use maybe something simpler. And you can also see what kind of qualification or certification kits the vendors provide. So maybe you can just find the fit you want. And I would say the most tricky part, which we always forget about in our development, is how to actually integrate a lot of artifacts, a lot of evidences we generate by the array of this, by the myriad of these tools we have to have in the development pipeline. So we need some sort of documentation evidence storage system. We need the system for storing releases and stuff. And believe it or not, it's well, probably there are some pretty fancy tailored systems for that, but my recommendation would be to keep it also a little bit simple, but understandable. So you come up with the structure and then use pretty simple tools like SharePoint or Confluence by Atlassian or Google Workspace, so you can kind of automate in a network manner, so it's accessible from everywhere, and by many people. You can come up with your documentation structure. It shall not be super sophisticated, it shall not be extremely automated in terms of generating super nice reports altogether, but it shall have some ground rules and structure. So what you put where, how version number, different evidences and stuff like that. So it helps to have basically everything at one place. And what I also want to mention specifically is that all of you who are dealing with functional safe products, you need to remember that if something goes wrong when your products are at the market and you receive the claim, you will have to respond to that claim. Otherwise, you will have major financial risks, because normally it's the products you're dealing with are hazardous in terms of their malfunction. So, and like even for any CE marked product for European market, all vendors are obliged to store the information for next 5 to 10 years to be able to present that as their quality mark and responsibility mark in terms of product development. So here in functional safety products, it's even more important. So you need to remember that you have to really store all the data and store it for a long period of time. So that's all from me on the on the tools, and I'm happy to pass the microphone to Vadim, who will be concentrating on actually tricks. So, Vadim, the floor is yours.
Yeah, thank you very much, Alexander. Okay, so if you have tools, now we have to think over about some tricks and techniques, what we have to do. First of all, when you develop your system, consider key components and look into safety capable components. Specifically for complex components like MCU, system on chip, FPGA, or if you select an operational system, consider or just if you want to do safe product, look first into components which can provide safety features, and when they claim that they can give you this ability, it improve or accelerate the process of certification. This component cannot replace all the certification. So if you put all the components which are safety capable, it does not mean that your system is safe enough. Anyway, all the process should be done, but some of the steps could be eliminated or reduced. Specifically for development effort, if you take these components, it provides quite native features which does not require some software implementation. It provides good diagnostics diagnostics features like error code correction on flash memory, on RAM, or it could be CPU lockstep, or it is error signal models and other stuff that helps you to prove that your system has enough capability to be safe. And if you can cut development effort, obviously it leads to time to market, efficient time to market. Negative part of this is BOM cost. This component is not so spread, and the cost there slightly high. And if you have very high volume of your product, you have to consider what is better. And also some functionality, expect that some functionality of these safety capable components are cut. So because just to introduce these extra features, manufacturer or vendors, they cut their some sacrifice with some functions. It gives manufacturer provides a good evidence like safety manual, FEMIDA, heat data. It is available, and you can reuse this in your design, and it much fast accelerate FEMIDA for your product because you have all inputs. And also certification also easier if you use some well-known manufacturer. All this certification bodies know them, and it also accelerates the process. Okay. Use vendor safety packages for many components, even if it is not safety capable by default or by manufacturer. They provide vendors provide good safety packages. It is for microcontrollers, for FPGAs, and this safety package contains data which is needed for certification, like FEMIDA results, feed, diagnostic libraries, self-test routine, errata sheets, and a list of tools which should be used for your product. And start from this one to read how to use this and what the features you have to take to be on safe side. One of the example of this safety cable component is a lockstep MCU. It is two. This MCU contains two similar cores, which is rotated on 90 degree physically on the crystal, and these two cores, they execute the same code instructions, and between them is comparator which compare the results of each program line. And if result is incorrect, it generates a hard fault, and it allows you to transit your system to the safe state by detecting these errors. It is quite powerful technique, which comparable with 1 out of 2 plus diagnostic architecture. So it is like a double channel, but in fact this is 1 out of 1 diagnostics, because the shadow CPU does not have output. So you have to only one output and error signal for this one. And these parts, they are built inside the MCU. You don't need to heavy diagnostics routine to check MCU arithmetic part or bus or whatever. It is much easier from software perspective, from resources to perform your main for your core functions. Yeah, and just I forget to mention that usually we have to look into complex components for safety capable components. Usually it is complex components which requires a lot of diagnostics to build by with software, and it helps you to reduce this effort. Okay, the next trick is called like black channel concept. So it is well described in 61508 standard. And what is the idea? If you use kind of simple communication line like RS485, it is quite 1 or 2 layers. You can prove that it is good enough to provide safety. But if you move into something more complex, like TCP or Ethernet protocol, or maybe if you use some wireless protocols for communication, which contain a lot of layers, and obviously you are not able to deep inside this layer to prove that they are good enough. And for this purpose, you can use like a black channel. You are considering your protocol, which is lower level, as a black channel, and you just don't care how it works. But on top of these layers, you have to put your own protocol level which provides enough measures to be safe. So these measures, like you have to put a protocol version, sender ID, a message ID, a sequence counter, and payload. And of course, it should be all of these should be closed with CRC 32 or 64 to be safe here. And also developing your own protocol, you have to look into a safe reaction. So if you have some rate of corrupted messages, you have to go to the safe state rather than trying to best recovery effort. Because if you have bad channel of communication with a lot of errors inside, you can detect that the CRC will be okay, but message will be corrupted, and it will lead to unsafe operation. So this is what is for black channel. Yeah, next one, it is safety isolation. If in your MCU, if two codes coexist, like non-safety and safety, it makes sense to separate them to avoid interfering from non-safety part to safety part. If we're talking about MCU, we are using a memory protection unit, which can protect safety functions from interfering from non-safety code. Also, one of the good trick is TOS isolation. So it is when operational system use MPU to separate tasks from each other to avoid any corruption of memory or any interference from one task to another task. And also a good point, but obviously if you have two parts like safety, non-safety, they somehow should communicate to each other to transfer data between them. And we have to look into privilege control interrupt, which allows to execute or to execute communication between these two parts in safe way. This is what we have to say about this. Yeah, look into Watchdog. Watchdog should be implemented well. Windowed Watchdog is a good measure to monitor and to control that your controller works as expected. And the watchdog should be independent. It is not necessary to be external watchdog. You can use internal, but be sure that this, even if you use internal watchdogs, that it is independent. So that watchdog does not use the same clock, because obviously if it uses the same clock, if clock is failed, everything will be okay, but you will never detect this. And implement software in a way that some special component will care about watchdog and monitor like a scheduler when monitors that all tasks or all functions in your main is executed in the right way and maybe with the right time, and only if it is everything is executed correctly, just only in this way feed watchdog with pulse to say that everything is okay. One of the important thing it is voltage supervision. Specifically over voltage and under voltage also is critical here. It is one of the root cause of common cause failure, and you have to be very careful here. And any anomalies on your power rails should lead to the safe state. And if you see that over voltage and it is quite heavier fault, because it is difficult to control consequences of this fault, and you consider, do you need a safety lock if this voltage is detected, just to de-energize all the system or to transit to the safe state to be quite guaranteed that even under over voltage you can go to the safe state. Yeah, self-test and diagnostics, it is what you have to think over how to introduce, how to do. We are recommended to define the safe state. So it is what it is if you control with motor, it should be energized and no power, no output power. If we're talking about valve, you have to define what is the safe state for the valve, opened valve or closed valve. And if diagnostic detects something, you have to provide this safe state. On startup, make a diagnostic for your RAM, for or peripheral, and also consider periodic diagnostics on the MCU, because it is quite important. For diagnostic coverage, use your FEMIA and also architecture design where you defining mitigation action on faults.
I think if I may add, Vadim, shortly, if you go to the previous slide.
Yep.
This startup and runtime diagnostic sometimes looks overwhelming, especially for teams who are not used to do this. But nowadays, many vendors provide, like the same version of the microcontroller with the add-on like functional safety package. For instance, Atmo Microchip, which is now the same company, they provide more or less the same processors where you can choose the microprocessor that has these tests as the digital automator implemented into the core. So it's some sort of peripheral. You can just hook that peripheral and say, now please test, RAM. And then it can allow you to configure this peripheral to test specific parts of the RAM by blocking, like other peripherals to access those parts of the RAM. So and then it works, extremely simple. You can just configure it once, and then you just need to respect that such test may occur during the runtime, and just remember about that. It doesn't make major problems. So that's just what I wanted to add.
Yeah, thank you, Alexander. Yeah, and also if you look in not safety capable MCUs, they quite so diagnostics will take quite a lot of resources. Even if you use a library from manufacturer, it takes a lot of time. um, I mean, computation time or MCU time, and also it requires flash memory to put these libraries, and it could be quite heavy for implementation. And also, of course, software implementation. It gives you a lot of limitations. Just imagine if you need to check your RAM, if it does not have incorporated measures. So you have to put some region by region and check that all cells, all bits are okay, there is no intersection, and it is quite heavy to do. Okay, just a huge checklist. What you must have in your design for communication. You should have CRC, sequence counter, identification, timeout, and check data not only by CRC but also on logical. So you have some valid range. You have to validate as well, and it should be done by from end to end in communication between any components you have. If you are using a CPU, at least you have to have a watchdog, windowed watchdog. Uh, it should be at least independent clock, and post reset you should clock to understand how to react if you start up. Maybe you have to lock your MCU and go to the safe state for the power down. Memory, does it have ECC or other test, RAM test, and how to do this? It is very important part. And of course, power, under voltage, over voltage, how it works, how you manage this, what happens is over voltage occurs, and how it spread on the board, cannot damage other parts and only MCU, and how to make it safe. And of course, isolation. Do you use MPU? Do you use privileged operation gates to correctly enter and transfer data between safety and non-safety part? And what is pitfalls? If you are thinking that only CRC is sufficient without other measures, be sure this is not. If you feed your watchdog from a timer, it also unfortunately doesn't work. If you disable your error code correction on your memory, it also bad sign, and that is why you need these tools and continuous integration to be sure that it is not. And of course, if you allow in direct or even sometimes indirect access to safety related peripheral like pins or whatever, it is not allowing, most likely you will fail your certification process. Yeah, I think this is.
Thanks, Vadim. There were some tricks and recommendations from Vadim that are, super practical. So that's basically all the tools and tricks we wanted to show you today. So now we have time for questions. So please either unmute yourself and ask them, or type it in the chat. What I want to present in the meanwhile is that we will actually have, for those who survived now 4 webinars and still love functional safety, which I hope you do, we will have one more webinar that will be, I would say, a mix of actually your cases you would want, and maybe extended questions you would want to ask. And also, we will walk you through some quantitative characteristics and requirements that you have to put into the architecture and calculate, and actually what you want to calculate and why, based on the on the standard requirements to later on to create some evidences that your product is safe. So that what will be presented during the webinar number 5. So please make sure that you register for it. So now time for questions. I can see there is something in the chat. So maybe Vadim, you can read it. So it's because it's a bit more easier for you.
It is about AI, but I just let me see the where we can find messages. Oh,
You have a chat window in the bottom of your screen.
but I'm not sure that I have to somehow turn on this. It is about AI, yeah, as far as I remember.
Oh.
What? But I don't have this somehow.
Okay, let me see if I.
Maybe.
Yeah.
Okay, so I see this. Yeah. Okay, a question about the very beginning of the webinar about the use of AI. How exactly the use of AI is prohibited in relation to functional safety? What about AI and as an auxiliary tool? Yeah, it was like a joke on the beginning, but AI is prohibited to use on decision making in the safety system. So you can use this as a support tool, but you have to be competent in the question what you are asking AI. It also can help you, but cannot decide instead of you. And you have to remember that AI is not responsible for the decision humans should do. And also, if it is prohibited to integrate AI in decision loop or in control or safety control loop. So if it is online function, which should define so pressure higher and it is slow, and we have to activate safety state or do not activate safety state in this area, AI is prohibited to be used.
What I think I can add is that there is a specific type of AI instruments called explainable AI that can be and starting to kind of have their own, I would say, life in also in safety related and cybersecurity related applications. We don't have major experience in using the explainable AI in our solutions. Maybe it's more, typical for bigger systems, but in the projects we normally do, we don't have any experience in actually certifying products where either during the development you use AI as the evidence generator, or you use some sort of machine learning algorithms to be able to kind of produce the safety function. We don't have experience about that. It will probably come soon, faster than we believe. But for the moment, we don't have such experience.
I can only just imagine that it could be used if you have a safety function developed in classical way with no AI, and also you just add this on top to maybe to detect some anomalies and just to improve what you have on classical developed system. So, for instance, you have SIL2 controller and you build the system and you want to little bit improve or just to say that you improving your quantity of characteristics, and you just add this on top of this in parallel with no any interaction, just to monitor it and say, okay, we suspect that something wrong here. Please look into this only in this way. So I can imagine only like this one.
More questions, colleagues? Any questions to me or Vadim? What can we help you with? Yeah, the Mitre says that people are trying to put AI everywhere. Well, that's correct, but we have to be careful with letting AI to rule over our experience and just, general engineering knowledge we use. So while people are probably typing more questions, what I want to say is that we in EKTOS Development, we provide our help and consultancy on functional safety projects and development. So, and we can do, many things. We can do, like a full scale project for you, but we can also consult and do some peer review or, whatever, helping you to do some specific processes inside the company or help you with reviewing, suggesting different, tools and techniques which can streamline your development within your team. So that's what we can help you to do in your projects. There is one more question regarding version control. Is it critical for functional safety to have its own server, but just a corporate security? Well, let me take this one, Vadim. In my mind, in the modern world of cybersecurity, there are different takes of different organizations. My recommendation to customers is to keep as much as possible of IPR in-house. So even if you have the product owner, the company that owns the product, I normally suggest them to have their own hosted server, maybe in-house or in a data center with good, backup and stuff like that, but then still have customer or product owner to be in charge of the server. And then all others are connecting via sort of VPNs or whatever else to that version control, and then work on that version control server whenever people are placed. Today, a lot of people are working remote, so that would be the good way to do it. So I don't think there is any specific requirement to have server in-house or in data center for functional safety, but for cybersecurity reasons, there are a lot of limitations. And my recommendation would be to host it either at a very good and protected data center or in-house if you have enough specialists to actually, I would say, to be able to control and manage this IT infrastructure. Any more questions, colleagues? No? Well, then I think we will be closing our webinar for today. I'm very happy to have the good group, and I can see the similar faces now in the chat and also in the participants. So it's really nice to have to have the powerful group who is interested in functional safety. And obviously, we would want you to fill in the feedback form so we can do our next webinars better. And for those who will fill the form, we'll obviously deliver the presentation materials in a better resolution that I can see and the PDF we have been showing today. Sorry for that. But you will have all the materials, and obviously we would want you to see you. We want to see you on our webinar number 5, the secret Easter egg webinar about calculations. And please bring your safety cases. Please bring your challenges. So me and Vadim will be happy to support you, and then we'll have a couple of more software and hardware guys from our team to be ready to to crunch some tough nuts for you. So thank you, everyone. We are looking forward to see you on September 18th, and I wish you a wonderful evening and stay safe. Goodbye.
Bye.